Hi, and welcome back to another episode in the C# Practical Funkiness series. Today we're going to implement the validated of T type, a structure that's often modelled as an applicative functor in functional programming. If you recall the episode on map, we saw that simply adding a mapping function to a container without enforcing the rest of the monadic laws effectively turns it into a functor. In a similar way, and we don't dive into that part just yet, if you add a function that lets you apply a function inside a validated, like a validated of function from T to R to a validated value, then you've built what's called an applicative functor. So what exactly is a validated of T? It's a type that represents the result of a validation, meaning either we have a valid value or we have one or more validation errors. Now, unlike something like a result or an option, which usually stop at the first failure, validated is designed to run all the checks and collect all of the errors. This makes it perfect for things like input validation, where we want to run multiple rules like checking the length, checking the format, or making sure that the value isn't null, and return everything that went wrong in one go. So to sum it up, validated is about gathering feedback, not failing fast. It's especially useful when you want to validate a bunch of fields and give the user a full list of issues, not just the first one. Today we'll do this using a simpler method than the traditional approach. The traditional way we'll look at in another episode can be a bit mind-bending for most people, and that includes me, especially since C# doesn't have built-in support for currying. Okay, let's dive in and take a look at how validated of T is implemented. Now I'm going to assume you've already seen the earlier videos, especially the ones on result of T and option of T and partial application, because I won't be explaining those again here. You don't need to fully understand everything from the previous videos. You just need to appreciate how these ideas add to your functional toolbox as we continue layering on new techniques. Now at this point, given how similar all these structures are that we have discussed, I will not go through it line by line. As you know the pattern, something is either good or bad, and those good or bad values are kept private, forcing the user to use methods such as match to think and provide information for both cases. The result of T was success or failure. The option of T was some or none. This one is valid or invalid. Unlike the others, the SAD path holds a collection, and in this instance, rather than just a collection of strings, I have used a simple record called validation entry, which just has three properties: field name, display name and message. But you can use whatever best suits your needs. From experience, when receiving validation information, it's nice to have the field or member name for the developers and the display name, or what the user sees, that most likely matches the on-screen field label names. One thing that I should point out, in keeping with functional programming principles, I've added a map function to the validated type, effectively making it a functor. But you should be aware, it's not map's job to enforce validation rules. Its role is simply to transform the value inside without changing the validation status. This means you could, for example, use map to transform a valid value into something that would actually fail validation. In such a case, map would still wrap it in a validated because it doesn't perform any validation itself. Because of that, you might decide to omit map in your own validations if you want to strictly control when validation happens. Now let's quickly look at the validation entry record before moving on to the main point of today's video, having a structure that accumulates its failures, unlike the other structures that short circuit. As you can see, nothing much, just a simple record struct with 3 properties. Again, use whatever works for you. Alright, now on to the extension methods. I've added 2 overloads of a method called combine. You'll notice that to support more arguments, you'd need to copy and paste and add additional overloads for each extra parameter. This is the trade-off of having a method that does exactly what we want, accumulating multiple validations, without the added complexity of an apply method, which is used in the full applicative form. Let's walk through the first of the combine overloads, as the other and or others would be identical, just more params and if statements. The first combine method chains on a tuple containing 2 validated of t types and accepts a function accepting 2 parameters t1 and t2, returning a tout, with the combine method returning a validated of tout. On line 11 we deconstruct the tuple into 2 variables, first and second, after which we create a new list to hold any validation failure entries. We then add any failures to this list. Finally, if there were no invalid entries, we return a validated of tout in a valid state, providing the function builder with the valid values which it uses to produce the tout value. Looks way scarier than it actually is when you see the example. Otherwise, we return the full list of validation failures in the invalid validated. Before we move on, I just want to point out that I've also added a toResult extension. This allows you to convert a validated of t into a result of t. Now personally, I prefer to return a result type from methods rather than mixing multiple types throughout my code. But there's no right or wrong here, just use whatever works best for you and your situation. To support this, I added a new result failure type that can hold a collection of validation errors. That said, for these demos I'm keeping things as minimal as possible, otherwise it becomes too much to hold in your head all at once. Because the base failure class I used for a previous demo didn't include support for collections, I'll need to cast the failure when we use it shortly. If you're curious how I normally structure my failure base class, check out my flow repository. As a side note, there's nothing wrong with using either a validated type or a result type to return validation information. It really depends on whether the object you're validating can exist in an invalid state or if it should never be created unless it's valid. For example, libraries like Fluent Validation typically validate existing objects, which means those objects can be constructed first and validated afterwards. But in some cases, especially in your domain model, there may be objects that should never exist unless they're valid, and for those, the validated of t approach really shines because it lets you enforce correctness at the point of creation. In the demo, we're going to validate a FullName domain type. This is a value object that's typically used as a method parameter instead of passing around raw strings or other primitives. But before we look at that object and its static factory method, sometimes called a smart constructor, we first need to look at a small utility class I've created for the demo that it uses. It's called validation functions. Right now it's just a function factory for creating validation rules using my current favourite technique, partial application. As I've mentioned in previous videos, I find myself using partial application more and more. A couple years ago I probably would have dismissed it as being unnecessary, but now I really see the value. Funny how that happens. Okay, so what does it do? The create regex rule method takes in a regex pattern, the failure information to use if the match fails, and any regex options needed for the rule. It returns a function that just needs a value to validate, and that function gives back a validated of t result to its caller. Likewise, the create predicate rule method does the same thing, but instead of using regex, it relies on a predicate. Finally, something that should feel familiar by now, there's an and then extension method for chaining validation rules. Now, strictly speaking, this isn't classical function composition, because we're not passing the output of one function into the next. Instead, both rules operate independently on the same input, and their results are combined, with any validation failures being accumulated. This makes it easy to build up layered validation pipelines that still work nicely with our combine method discussed earlier. Let's now look at the FullName type that we only allow to be created in a valid state. Now, before I continue, whether or not these rule functions should be placed within the record class or retrieved from another location is really up to you. I placed them here so we could see everything together. We could have easily called something passing some key to get back a ready-made function. For this demo, the validation rule functions are stored as static fields, so they're created only once and reused every time a full name is validated. This makes the solution both memory efficient and performant. However, if you need to change validation rules at runtime, say loading patterns from a database, this static approach might not be suitable. I chose to keep the rules inside the type so you can see how everything works together. On line 15, we create a regex-based rule function that checks whether the input matches one of the acceptable titles for our FullName type, like Mr. or Mrs., etc. On line 18, we define another regex rule. This one checks that the given name starts with a capital letter and is between 2 and 50 characters long. The exact regex isn't important for today's topic. We'll save that kind of discussion for another day. Now, on line 22, I've changed things up a bit. Instead of using a simple single regex, I start with a simple predicate that checks the length of the family name. Then, using our and then extension method, I chain it to another rule that uses a regex to ensure that the name starts with a capital letter. It's similar to the previous regex pattern, but without the length part. There are a couple of reasons why I did this. First, I've used regex for many years and there's not much you can't do with one. But more importantly, I wanted to show how breaking rules down and composing them can sometimes give a better user experience. Take the given name rule for an example. Its failure message is already a bit long, trying to explain both the formatting and the length requirements in one go. And yet, what if the failure was caused by something like 2 consecutive spaces? That's not allowed, but it's also not mentioned in the message. By splitting validation into smaller parts and composing them together, we give users short, specific feedback for each issue. And because the validated type is designed to accumulate failures, users will only see the messages relevant to what actually went wrong. In my opinion, that's a great approach, especially for more complex validation scenarios. That just leaves the static create method, which takes in a few primitive value like strings and returns a validated of FullName. If all the validation rules are met, we get back a fully constructed FullName instance wrapped in a valid result. Otherwise, we get back a collection of validation failures. Here's how it works. We create a tuple of 3 rule functions, which are immediately executed as soon as the method is called. That gives us a tuple of 3 validated items, 1 for each field. We then call our combine method on that tuple, and for the function parameter that combine expects, we simply pass in a lambda that says, if all goes well, use these values to create a new FullName record. I know this might feel a lot to take in all at once. Don't worry, just rewind and go through it again until it starts to click. And as always, I strongly recommend downloading the code and trying it out yourself. Everything is freely available on GitHub, and you'll find the link down in the video description. Alright, at long last, let's see the demo code. Very quickly, on line 13, we create a full name using a valid title, but we only provide a single uppercase character for the given name. This will fail the length part of that regex rule. We do something similar for the family name. However, since that rule is split into two parts, one checking the length and the other the format, we should only see the failure message related to the part that didn't pass. After that, we print out any validation failures. Just to demonstrate how easy it is to convert to a result type, we call the toResult extension and then use its extension methods to print out the failures. As mentioned earlier, if the failure base wasn't just demo code, we wouldn't have needed the cast here. Next, we try another full name using values that should pass all of the checks. We then use the getValueOr method to print out what's inside the validated instance. Alright, let's run it. And with that, I think we're done for today. In the next episode, we'll add the applicative part just for comparison, so we can turn this into a proper applicative functor, side by side with the combine method we've been using. I hope you found something useful or interesting in this video. As always, feel free to leave feedback, good or bad, and I'll do my best to respond to any questions you have. If you found the episode or source code helpful, please consider liking and subscribing. It really helps the channel to grow. Thanks for watching, and until next time, bye for now.